Um, so, good morning all. I'm Michel Racic. I'm one of the leads of GDG Zurich, and I'm working at Credit Suisse as a test automation software engineer. And I'm gonna tell you a little bit about the page object pattern and Selenium today. So what's Selenium? Basically, it's used for testing web GUIs. It's not intended for backend testing, but it can be used, and it probably will be used in combination with it. It's widely adopted by the industry and backed from big players like eBay or Google. It also allows cross-browser testing, but more on this on the next slides. So I won't explain why automated regression testing is important or how to get to your tests. This would cover a couple more hours of talking with you. Today we will have a look at Selenium WebDriver, which is not a tool itself, but rather it's a library that you can use and it's hiding a lot of boilerplate from you. You can use your preferred framework for driving the tests like TestNG or JUnit or whatever you prefer. You can even use plain Java to use WebDriver. One of the biggest benefits of Selenium is its ability to do cross-browser testing. So you can run the same test on against multiple browsers like Chrome, Safari, Internet Explorer, Firefox, Opera. And yeah, you can also use headless browsers like HTML-Unit or Phantom.js, which helps you in doing unit tests because they're very fast compared to using a browser with a GUI. And yes, it's it works cross-platforms, so you can run it on Linux, you can run it on OS X, on Windows. That's all no problem for Selenium. But what about mobile phones or tablets? So yes, it also works on Android and iOS. All you need is the corresponding driver, and Selenium hides the specific implementations from your test code. So, what do we want to achieve today? We want to simplify the tests by abstracting the view from the code. So we want to reduce the maintenance costs, and we achieve this we map real-world objects to classes and fields and reuse them in a lot of test cases. We create functions from the actions that can be done on those objects. So about the page object pattern. This is an abstract view of the concept that that at least at my work we try to use, or we use. It's splitting up the parts into 3 different roles. So you have requirements engineering, you have development, and you have testing. So it starts with requirements. Everyone needs requirements in one way or the other. From the requirements, a developer will implement the application, while a tester will actually write his test cases based on the requirements. Then in the page object pattern, we can create an interface based on requirements. Having the interface based on the requirements lets us write tests before we actually implemented the application. This allows us to build a regression suite while development is still in progress or even hasn't started yet. And I will show you a little management conclusion, which you can use as arguments against the management why you use that pattern. So the benefits are clearly for the testing side. The testing team needs to do less maintenance because they're working closely together with the development. They get involved early, not only after the application has been developed and put into an integration test environment. And they can reuse artifacts from development. Basically, the page objects will be in the responsibility of the corresponding developer. And if he updates as soon as he changes something, the automated test cases from the testing side will still work because they use now the updated page object. Developers get a more stable staging quality because if you already have a big regression suite that can run in a continuous mode, you will find defects and bugs and mainly config errors very early after deployment. And it also improves the requirement quality because in the process of creating the interfaces, you will automatically find requirements that maybe don't match, that need to be refined, or that are not clearly written what they should do. And reusing the artifacts from testing, because as I said, if the test team already wrote some regression tests, why not just use them even on development servers, on the staging servers? For the project, the overall quality will improve, and they get clearer requirements, as well as a stable solution for long-term use. A mistake often done is after a project ends, the testing also ends. Means there is something, but the application is in production and is not developed yet, maybe for 1 or 2 years. And after 2 years, you have a new project extending that application, and yes, then you would be happy if you have a stable regression that you still can use, and not have to build something from scratch again. So that's the demo application we're gonna look at today. So that's a calculator if you haven't seen it. So what's the basic elements in a calculator if you just look at it? It's a question to the audience. Just abstract the calculator and just think you're a user. What's the basic what are the basic elements that you will need on a calculator? Buttons, yes. Display. And basically that's it. So we have a display. If we look at it, we can see number, but we are not able to directly interact with the display. So let's make a function called displayed, which will do the same as when we look on the display of a physical calculator. It will just tell the value of it. Buttons. We have a lot of buttons. We have buttons for each number, and we have buttons for each operation, as well as some basic buttons like clear screen. So whenever we press a button, something internally gets triggered, and it may even change the display. So let's also have functions for the action key presses. And finally, we have here, there's a button where we expect most of the time that we have to look up and read the results from the display. That's the equal sign button. Usually when you when you want to calculate something, you enter the number, you enter an operator, number again, and at the end, when you hit the equal sign, you want to see what is the result of it. So we will have a special function that will return directly the value of it. With that requirement, we can now design our interface. We can define the display function, which just returns us a double value in this case. And as you see, I return in most of the functions, I return the object itself. That's something I do because I'm like most of the coders, I'm lazy in typing, so I try to avoid typing a lot. And with the dot notation, I can achieve that, and I can even achieve that my tests get readable. So I get nice one-liner for assertions. So let's take a look at the test. Having the interfaces allows us to actually implement the test case. In the source on GitHub, that's the URL you see below, and I will also show you a bigger version of the URL at the end of my slides. You can look up my helper class and config files I use. So in the presentation I will only show snippets of the code, but the complete code which you can check out and run on your own is online. And that's what I mean with readable tests. You can see what assert does without analyzing a big block of code. It also hides the actual implementation and allows for a wide reusing of the page objects. As you see, I have the calculator object. I press the buttons in sequence, and at the end, when I press the equal sign, I can compare it with a value that I expect to be displayed. And here is some Selenium magic, which is the only part where you care about the end browser. So all you have to do is initializing the corresponding driver. Afterwards, you will have only one line of code and can start getting your first page object. That's also a helper method which is on GitHub. You see that I use the interface for getting the page object and not the actual implementation, because at this point we don't have the actual implementation, but we already have the test cases running. They will be failing, but they are there. This really splits the test from the implementation, and this allows also for several concurrent releases under regression at the same time. So let's have a look at the sample application. So we need to look at the application's output. That's the code what you get outputted in a browser when you go to that page. And we need to find identifiers for the objects. So whenever possible, use the HTML IDs, as they perform the best in most browsers. But don't expect any wonders from Internet Explorer. It works the best in all other browsers. When there are no IDs, and it may even be a third-party product, you have still plenty of ways to get your identifiers. So usually it's the most time-expensive option, but when CSS identifiers and the rest don't work, you can still, with XPath, you can achieve almost anything. So it's really powerful if you know how to use it, but it's also slower than the other methods. This is where we will spend the most maintenance time, and hopefully that page objects get used in more than one test. First, we declare the elements we need from the page as fields. Selenium has some annotation magic to make the connection. So you see I'm just using an annotation on a web element, telling it what is the ID, and when I initialize the page object, it will identify the button I want. In this case, yeah. So whenever you change the elements in the GUI, you will have to maintain the corresponding page object. And if you do it by the time you're changing your application, you also maintain your page object, your test will automatically run when you deploy, and not first break and then have to fix the test and then deploy again. So implementing the actions is fairly easy. As an example, to click on an element with the mouse, just call the click method on the web element object. Always get an abstract view of the action's goal. So a login, for example, can be implemented through two functions, set username and set password. But you could simplify the access and use just one function, login, with two parameters. Try to combine actions that a user would do, so the test gets more readable, and even you can show it to non-programmers and they will understand what the test is doing. So let's take a look at how this looks in action. And first we will execute it against HTML unit and the desktop browser called Chrome, which you may hear of before, or at least I hope so. So you see HTML unit is what you see behind is my config file, and this HTML unit is a headless browser. You will only see the log output, and you see all our tests are passed. So we switch, in this case I switched the config just to Chrome, but practically you would have several, you get the values from somewhere without having to change it manually. So now it's running against Chrome. You see it just does all the clicks what a user also would do, just a little bit faster as when you manually test it. And the results will be accurate because it's code that actually really compares the values. So next, because we are at the Android Developer Days, so let's see how it looks like when we run it on Android. So I switched config to Android, and you see, on my laptop I now start the test. I first start the WebDriver, which is an application I need to install on my phone or on my tablet, and open over TCP connection. It will talk with the test that's running on my laptop. So you see it starts the page in a mobile view and does the same what Chrome did before. It's a little bit slower, but that's the magic of Selenium. So without having to change my tests or even change my page objects, I can run it against various browsers on various platforms. And yes, that's it. So thank you for listening. Here you have the links for the presentation as well as the code. If you want to have some deeper look at the page object pattern, I also have on the GitHub page, I have a link where you find the files from my code lab, which I did last year, which will get you a deeper walkthrough about how to use the page object pattern with Selenium. And in the code lab, I'm not using just such a simple one-page application like the calculator, but I'm using a JamWiki instance with multiple use cases. Are there any questions?
It's more about the Android part. The driver for Android uses the web view. Is that right?
Yes.
So I can test everything that I would do within my application against the same web engine, essentially.
Yes, it's actually just an application which consists of the standard WebKit web view browser. So it's only testing the standard browser, not Chrome or Dolphin. But yes. Any other questions? We still have book. Yes. We have a book to give away. So who wants to ask a question to get a book?
I don't want a book, but I've got another question.
Okay.
Can I also run my own applications browser, or do I have to use the driver that you presented? So can I use my application if I have a web view in there? Can I use Selenium as well to test that?
Basically, you could do that, but then you would need to implement your own driver.
Okay.
So there's a standard protocol which you could implement and open a TCP port. So if the test can communicate with your application and your application understands the protocol, then you can do it. You're free to do it. Okay, then